Good morning, students. Today we are going to discuss few topics in related with the previous discussion of chapter 3, and the chapter 3 is your motion in a straight line. Now the topic which you are going to discuss is your speed. Now almost I think most of you know what is speed. Let me try to explain it here. So as per the statement specified here, speed of any object in motion is the ratio of total path length, and path length is nothing but the distance, and the corresponding time taken by the object. So let me to repeat once again. Speed of any object in motion is the ratio of total path length and the corresponding time taken by the object. So speed is nothing but is your distance by time, and the distance is nothing but is your path length. And in previous class already we have discussed distance is a scalar quantity. Now the SI unit of speed is your meter per second. Now let me classify speed. Now as per our syllabus, speed can be classified as specified here. So speed, uniform speed, variable speed, average speed, and instantaneous speed. I think till now you know speed, uniform speed, variable speed, average speed, but instantaneous speed I think you don't know. So the new word we are using, new types of speed, is your instantaneous speed. Now one by one we are trying to define these classification. Now let me start with the topic uniform speed. Now uniform speed, I think all of you know as speed equal to distance by time. So if an object covers equal distance in equal interval of time, then that speed can be defined as your uniform speed. So as per statement here, let me read out. An object is said to be in uniform speed if it covers equal distances in equal intervals of time. So if you plot a distance by time graph, then in case of uniform speed, it is a straight line passing through the origin. Now next one is your variable speed, and variable speed you can define as your non-uniform speed. So in non-uniform speed, what happened basically, speed involves two parameters. One is your distance and another one is your time. So variable speed can be defined if an object covers unequal distances in equal interval of time, or you can say if an object covers equal distances in unequal interval of time. That is also correct. So as per the statement, an object is said to be in variable speed if it covers unequal distances in equal intervals of time. So if we plot a distance versus time graph, so in that case, in case of variable speed, it is no longer a straight line, rather it is curve. Okay, now we have not specified any unit for distance and time in the graph because it is valid for all unit. If it is in meter, if it is in centimeter, if it is in second, if it is in hour, if it is in kilometer, so it is valid for all. That's why we have not specified unit here. Now next one is your average speed. So average speed, as per the statement, average speed of an object is defined as the ratio of the total distance traveled by the object to the total time taken. So average speed is nothing but is your total distance traveled divided by total time taken. Okay, so I think this one you know, but here we are going to study this classification elaborately. Now the next one is your very important one, probably you don't know this one, instantaneous speed. So as per the word instantaneous, basically this is the speed at an instant, and instantaneous speed is possible in case of non-uniform speed, and practically all speed are non-uniform in nature. Uniform speed is very tough. So as per the statement what we have written, let me read out. Instantaneous speed of an object is the speed of the object at a particular instant of time. Now let me try to explain this graph. Now this graph is your non-uniform motion, is not it? Because the graph is your curve. Now one axis is your distance axis, another one is your time axis. Now on the graph we have considered 2 points A and B, and for the coordinate A corresponds to distance axis as your x1 and time axis as your t1, and B corresponds to distance axis x2 and time t2. So what we have done, we have drawn line parallel to the axis from point A as well as from B. One line parallel to the distance axis and another line parallel to the time axis. Now here, as per the graph, delta x is nothing but is your x2 minus x1, and delta t is your nothing but is your t2 minus t1. Now speed at an instant, it means at a particular instant. But how can we define mathematically speed at an instant? That is the question. Now if we consider t1 and t2 is very close to each other, but it's not exactly equal. T1, if we consider delta t equal to 0, what happens basically? Under that case, T1 equal to T2, no? So if we T1 equal to T2, then definitely x1 equal to x2, no? But if we consider this delta t tends to 0, then you can assume that delta t tends to 0 means it is a particular instant. But under that case, x1 not equal to x2, because delta t is not equal to 0, rather it is delta t tends to 0. So if delta t tends to 0, then we can assume that t1 and t2 is no longer independent separate time, rather it seems to be a particular instant or a single time mathematically. So under that case, definitely there is a separation. Delta x is not equal to 0, because we are not considering delta t equal to 0, rather we are considering delta t tends to 0. Now delta x by delta t define basically speed, is not it? Now once we substitute this parameter limit lim, this is limit delta t tends to 0, it means what? Delta t approaching towards 0, and under that case you can assume that time is no longer two different value, rather it is a particular instant, and under that case delta x seems to be very small, but it is not equal to 0. So under that case you can assume that it is the velocity, or it is the speed. It is the speed at an instant. As we are discussing speed, we yet to define velocity, we'll discuss later on. So it is nothing but the speed at an instant under this condition. But if you don't put this condition limit delta t tends to 0, it is no longer speed at an instant, rather it is only the speed. So as we have to define speed at a particular instant, so that's why you have to impose this limiting condition, that is limit delta t tends to 0. So if limit delta t tends to 0 with delta x by delta t, then this whole thing we can write as dx by dt. Now dx by dt in mathematics we will get later on. It is nothing but differentiation of x with respect to time. T is your time, is not it? So how will you read out differentiation of x with respect to time? Now slowly we are going to the mathematics part. This is the speed at an instant, that is your instantaneous speed, and the general speed goes to the instantaneous speed under the condition limit delta t tends to 0. Now instantaneous speed is required when the motion is non-uniform, and practically all motions are non-uniform in nature. Uniform motion is very tough. There are many factors why uniform motion is not possible. If you ride a car on the road, so definitely the motion is non-uniform, because you are not supposed to maintain constant distance in constant time interval, or equal distance in equal time interval, is not it? There are many factors. Basically crowding is a factor you can consider. So practically all motions are non-uniform. That's why we are interested in defining speed at an instant. Now I think all of you have understood there is a huge difference between the condition delta t tends to 0 and delta t equal to 0. If delta t equal to 0, then t1 equal to t2, okay, fine, it's a particular instant, but under that case x1 equal to x2, you are not supposed to consider delta x not equal to 0. But if you consider delta t tends to 0, not exactly equal to 0, under that case you can assume that delta x not equal to 0. There is a difference between x1 and x2 under the limiting condition delta t tends to 0. So limit delta t tends to 0, delta x by delta t. Delta x and delta t, what does it mean? Delta, basically delta we are trying to specify any physical quantity whose value is very small. And here the difference is very small. That's why we have symbolized it as a delta x and delta t. So the mathematics part, if somewhere you will get limit delta t tends to 0 and delta t is in the denominator with the ratio delta x by delta t, then this whole you can write dx dt, and dx dt is nothing but the differentiation of x with respect to time. Now slowly we'll get in mathematics. This formula is very important because later on we are going to use this formula and also the instantaneous speed ddx x to the power n. In mathematics you will get in details, but here as you have to use, that's why I will give you the formula simultaneously which you are going to use in physics from mathematics. So ddx x to the power n equal to n x to the power n minus 1. This formula is very important, and in next class we are going to apply this formula in the numericals. So this is all about and slowly we are approaching towards mathematics, but you must have to understand this parameter. And if question is there in distance time graph, how will you define speed? So what is your answer? In distance time graph we can define speed by finding the slope of the graph, and you have to find the slope by considering unknown points over the graph. So it becomes more clear once you perform the practical, and you do have practical classes are also there. So please go through this part and try to find out your doubts. I think most of the term you know, but we are trying to explain it more specifically here. And the new topic which you have not got yet is your instantaneous speed, and we are going to use this one very frequently in physics. And in next class we are trying to define velocity, and for velocity you have to consider displacement. So speed is your scalar quantity because it is distance by time, and distance is your scalar and time is also scalar. So in next class we are trying to define velocity, and if time permits we will try few numericals. So this is all about. Please go through and try to find out your doubts. Thank you.